All right, yeah, working fine. Cool. So thank you for coming and welcome to Minding Your Own Business. So for those of you who don't know me, I'm Bernat Rafalis and I'm currently technical lead at Not on the High Street. And I want to talk to you about testing our code because I really hope everyone in this room is testing all the code that they write and that goes into production, right? Good. So if you're not, just come and talk to me after this and we'll have a chat. Even though it's known that developers can be sometimes a little bit special, we don't write tests just for the sake of writing tests. We write tests for a reason. And amongst others, these reasons are that we're going to have to run those tests later on. So you need to run your tests to make sure that the code that you're writing works. In 6 months' time, your colleagues are going to be running your tests because they're going to realize your code is actually quite crap and it needs to be refactored. And somewhere, probably in the cloud, a script using Jenkins or CircleCI or any other tool similar to those, we'll have to run our tests to make sure that the code is good to go and get deployed into prod. Turns out, though, that we don't always write tests. And I think everyone in this room is probably guilty of having done this in the past. Hopefully not anymore, not in the present. And while the reasons for that may be many, I think that they usually boil down into one of these three categories. So the first one is you just don't know any better, and that's mostly fine. You know, you may be starting as a software developer, and usually tests is not the first things they teach you. That's all right. You know, nobody knows absolutely everything. You just need to keep learning, get to know what testing is, why is it important, and start writing them. The second one, which is less forgivable, is that we are lazy. I'm lazy. Probably every single one of us in this room is lazy to a certain degree. And I've definitely been guilty of, you know, Friday, 6 p.m., time to just leave work, enjoy the weekend. And you think, you know, it's just a tiny bit of code that is not tested. It's going to be fine. What's the worst that could happen? I'll just deal with it on Monday. Then the weekend happens, Monday comes, and you've just forgotten completely, or you're dragged into something else, and this code just gets untested. And last but not least, and the one I'm more interested in this talk, is that our code can actually be very difficult to test. So definitely this has happened to me. You are asked to make a small extension to the code base, maybe a legacy code base. You do that, it's a fairly easy change, and then you open the tests to write a new test to cover this new extension. And suddenly, when you look at the test file, your eyes start to bleed, and you basically start questioning why did you get into software development as a professional career in the first time. So obviously, I'm not going to try for you to be less lazy today, but at least I'm hoping I'll teach you one technique to make your code a little bit less difficult to test, and in the process make those tests also a little bit faster. Now, disclaimer, I'm going to focus this on Rails because it's the framework I'm most familiar with, but also because I think Rails by design makes testing some of its parts particularly tricky, particularly difficult. And also because Rails is, I believe, one of the first development environments that people choose to start learning development. And while that's a positive thing, and I think it says a lot about Ruby and Rails, I think it's also important for developers to understand that the way Rails does certain things is not only the only way to do these things, but it's not even particularly a good way of doing these things. And I'm going to focus, as some of you may have suspected, on Rails models. So this is a snippet that you can find on the active record guides, on the official guides for Rails. And I'm just going to read it out loud very quickly. It says, active record was described by Martin Fowler in his book, Patterns of Enterprise Application Architecture. In active record, objects carry both persistent data and behavior, which operates on that data. Active record takes the opinion that ensuring data access logic as part of the objects will educate users on their object, on how to write to and read from the database. So this is a very long sentence. What it's basically saying is that active record classes are doing way too many things, right? So it's not unusual, and it's actually one of the principles of object-oriented design to have encapsulated in your class data that belongs to this class and behavior associated to this data. However, Rails, by using active record, decides to throw another thing into the mix, which is logic that deals with connecting to a database, doing selects, doing updates, doing these deletes. And this is actually breaking one of the solid principles, the first one, which stands for single responsibility principle, which says that you should actually try for your classes to just focus on doing one thing and doing it very well. So let's imagine we need to build a new Rails application, and this application is going to have users. Fairly simple. We start by generating the model. We've got a user that's going to have an ID, which is going to uniquely identify it in the database. It's got 3 attributes, which are going to be strings, title, first name, last name. And following the Rails convention, we decide to add a piece of business logic into the class, which is a public method called fullName that will give you a nicely formatted string based on some of these other attributes. So this is probably what the class would look like. So this is mostly auto-generated by Rails. I've just added the fullName method to it, which is pretty straightforward, right? It gets the title, it gets the first name, it gets the last name, it discards any empty fields on this array, and then puts a space in between them. Job done. 5 lines of code, I think. And it cannot get easier than this. So let's not be lazy, and let's write a test for this class. And this is probably what a test would look like. I'm going to be using RSpec because I quite like its syntax and its DSL. So again, this is a fairly straightforward model test in Rails. You require the Rails helper because RSpec needs to know how to load certain Rails stuff to run your tests. You describe a user class. You tell RSpec this is a model. And you tell RSpec that the subject of your tests is going to be user.create with some attributes that we've built in here. Still, simple test. Simple setup, sorry. When you go to the test itself, this doesn't pretend to be an exhaustive coverage of the class, but basically we've got 3 examples with 3 potential edge cases where title, first name, or last name are nil, and we expect the fullName method to return sensible things. So far, so good. We just go ahead and run those things, and the results we get are somewhat expected. We've got 3 examples. None of it fails. It's taken 1.3 seconds to load the whole thing, and the tests itself or themselves took 0.01753 seconds to run. Now let's imagine we cannot use Rails anymore. It's forbidden, and see what a class like this would look like without using active record. So I did this exercise for you, and because I'm a born optimist, believe it or not, I named this class faster user. So it has twice as many lines as the other one, and that's because we have to explicitly create an initializer for it that gets the 3 attributes. We put them into instance variables. We make those instance variables publicly available, and the fullName method actually looks exactly the same as before. So we go ahead, write a test for this new class, and again, it looks very similar. So there's a couple of differences. One is we don't have to tell RSpec that this is a model because it's not a model. In fact, faster user has 0 dependencies on Rails, doesn't need to know about Rails. And down here, instead of using create, which is an active record method, we'll just use new, which is the default way to initialize objects in Ruby. The tests look exactly the same. That hasn't changed. We go ahead, we run them, and we get similar results. 3 examples, 0 failures. Files took similar amount of time to load, 1.3 seconds, and the tests finished in 0.00424 seconds. Now, if we run both of these things together, and I have to apologize for the size of this slide, but I'm going to read this to you. You can run rspec with -p. That means profile my tests, and it will just time the tests and give you some nice numbers at the end of it. No surprises here, 6 examples, 0 failures, similar amount of time to load the whole thing. However, if you look at how long it took for both of these classes to be tested, the difference is quite important. So the user tests took, on average, 0.00577 seconds, and the faster user tests took, on average, 0.00121 seconds. Now, unless you have some sort of superpowers as a human, chances are you're not going to be able to tell the difference. But if I show you these numbers in a different way, you know, things are quite different. So if we take faster user as our baseline experiment, we can see that user tests take 4.77 times as long to run. Now that's huge difference. So I don't know about you, but if I saw these numbers, I would try to figure out what's going on. So let's try and do this. We've got the 2 classes here, side by side, sort of. And again, the one at the top seems pretty straightforward, 5 lines of code. The one at the bottom is similar. You need to explicitly do some more things, but apparently, one could argue that the one at the top is actually much simpler. However, if you open a Rails console and ask Ruby to give you some numbers back, you'll start to figure out maybe what's going on here if you haven't already. So this is telling us how many class methods and instance methods both of these classes have. So users got 646 class methods. Faster user has 179 class methods. And if we go to instance methods, user has 404, and faster user has 96. Now, if we look at the classes again, those numbers don't quite add up. So I can see just one instance method here, constructor, and we saw that faster user had 96 and 179. So all these extra methods are coming from another class that you don't see here, which is the object class. So in Ruby, by default, if you declare a class like this, it automatically inherits from object. An object comes with some methods of its own, and because inheritance works like this, your class automatically takes all these methods with it. So that's probably giving you a clue of why is the user class actually so much slower. And the fact is, in the first line, user is actually not just a plain old Ruby object. It's not a simple class. It's actually taking in all the code, all the behavior of another class, which is active record based. And that makes this class actually much more complicated and slow than faster user. So for those of you who are not Rails developers and may not know much about this, at the very least, when you want to start using the user class, Rails needs to do the following. It checks what the class name is, and it gets user. It downcases the string and pluralizes it, so you end up with a user string. Then it connects to a database, searches for a table there that's called users, and queries how many columns are in that table. And then for each and every single one of these columns, it dynamically generates through metaprogramming a bunch of methods like getters, setters, finders, probably some sort of validation, and whatnot. And as we know, everything in computer science or everything in programming has a cost. And when this involves actually hitting a database, the cost just grows exponentially. So if we try to optimize our tests for user, we can get a little bit creative. We can say, actually, I don't need to use create because I know create will go to a database and try to write something into it. And actually, to test my full name method, I don't actually need to hit any database. So let's go and use new instead of create. Let's run both tests again. And we can start to see some improvements, right? So we've made user twice as fast. However, compared to faster user, it's still 2.3 times slower. Turns out, though, the faster user, or at least the test for faster user, can also be optimized. So we've seen in some of these examples that it takes 1.5 seconds, a little bit less, to load the whole thing. So if we look at this test, as I mentioned before, faster user is not a Rails model. It doesn't depend on Rails. However, in the first line, you can see that we're requiring Rails helper. So that's actually not needed. This class knows nothing about Rails. You should not require anything Rails related to test it. So let's change the file slightly. Let's require just spec helper, which is something our spec needs to run the tests. And then let's explicitly load the class that we want to test, because one of the things that Rails actually gives us is auto-loading of constants. So if we didn't have that line, our spec would fail, saying, I don't know what faster user is. The rest of the test remains unchanged. And then we go and tweak a little bit our gem file as well. So a typical Rails gem file will have Rails in it, and will have some other sort of like helper gems if you want. However, again, as we said, to test our faster user, we don't actually need all of this crap. So we'll create a gem file, which is called, I don't know, faster tests, gem file, whatever. And we'll just have it only require RSpec. So when you go and run the tests again using this gem file, you can see that we've gained a few more milliseconds when running our tests. And actually, we're actually loading the tests orders of magnitude quicker. So we've gone from 1.3 to 1.5 seconds to 0.09, which is quite the change. So I guess what I want to get at after this first part of the talk is, while those numbers are at the milliseconds level and they are quite small in absolute terms, chances are your Rails application is not going to have one user or two users. You're going to have hundreds of those active record classes, and you're not going to have 3 tests for each one of those models. You're going to have a few tens. So slowly but surely, as you add code to your application, and as you keep running those tests, these numbers start to build up, and that's how you end up with a code base or with a test suite that takes much, much longer than it should to run. So we could just say, OK, that's easy then. Let's just not use active record whatsoever. We're going to be all happy bunnies, no slow tests, no databases. Everything's going to be fine. However, that's not quite true, because obviously, we still need to store our users in a database. We still need to get our users from a database. So while having objects that just focus purely on business logic is definitely a good thing, you still need something dealing with connecting to the database and manipulating all this data. So one way of doing this, which is not very extended or widely used in Ruby, is using data mapping techniques and repository techniques. And what this pattern proposes is to just have a very clean division between what's accessing your data stores, which in this case is a database, and your business logic. So this is a very, very simplified version that I'm going to show you on how you could apply a pattern like this in Ruby. So you would still keep your business objects as they were before. We can, for example, put them in a namespace called business. You still have your database. That hasn't changed. You still have your active record classes. You put them in a namespace called data, and you use them for talking to the database and only that. So any business logic, like the full name method that was here before, just gets stripped out. And the way you bridge between these two things is through another class, which we can call a repository. So the important bit here about repositories is that even though you cannot have really interfaces in Ruby, you should think of those things as interfaces. So what you're going to do is define a very whose job and only job is go and find you business users from somewhere, persist those business users somewhere, and maybe delete these business users from somewhere. And one particular way you can implement this is through active record, right? So if we look at what the code would look like, you've got a business user, that's the same class as the faster user. We've just made it into a namespace called business, and we've added an ID parameter that the data mapper will need to figure out where to store this in a database. Our data classes are almost unchanged as well, so we make them into a data namespace, but it's still a user class that inherits from active records, and you may want to be helping active record a little bit, telling it what table to look for in the database, because by convention, things that are in a namespace will just resolve to different tables. And maybe the most interesting class of this exercise is the actual repository. So again, this is a very simplified version of how to do this. It's not production-ready code, so don't do something like this. But in a nutshell, you could have an object called repositories user. You initialize it with an active record class, and it's got these three methods. Find will go to active record, do what's effectively going to be a user.find, and then the data mapping happens here. So you'll have either a private method in this object or a separate object that will know how to map the columns in your database to the attributes of your business object. Delete looks something similar. So you would go to the database, find that user. If you can find it, just call destroy on it. And persist would be slightly more complicated because you would have to ask if that is a new user that still doesn't exist in the database or not. And depending on if it's a new user or not, then you would just create the user in the database or update an existing record in the database. So the way you would then go and use this repository would look something like this. You go and create your users as usual. You don't have to worry about databases or creates or updates or anything like that. The moment you're happy with your object, you create a new instance of your repository and just call the persist method. You pass in the business object, and this is where the database create happens. Second usage scenario, you've got, there's a user out there. It's got the ID 3. You do repository.find3, and this will give you back a business user, and then you can just start using it as you would any other class. Now, you may be thinking, is it really worth it? Right? So in the old world, you just inherited from active record, put your business logic into it, and off you go, right? And yes, it's going to make my tests a little bit slower, but I really just can't be bothered with building all these repositories. And not to mention, obviously, the repository is a new class. You're still going to have to test all this. So I'm going to show you yet another code snippet that hopefully will convince you that using a pattern like this is actually very beneficial. So imagine our product owner comes to us and says, we've got a new requirement. We need to be able to send letters to our users, but we just don't want to print just a generic letter. We want to have a personalized greeting at the top. So I want a system that I can give a user ID and the contents of a letter, and I want back a string which has those same contents, but with nice full name of that user at the top. Now, if you were to write this the Rails way, I can, like 90% sure, guarantee you that the code would look like this. You'll have a letter class with a method that I've called generate that gets a user ID, gets some contents, and here you would do user.find user ID, and then do some interpolation of strings, and off you go. Now, what is the problem with this class? The problem with this class is that it's actually having an implicit dependency, right? We're saying this letter has to know about this class, which is called user, and in here we're doing a database access. Now, in production, that's how the code would work. We would go to a database, so it's not like we're making the code much worse. However, when you start thinking about how you're going to go and test this, you will start to see that things are not quite right. So basically, you've got two options when you want to test this. One is you need to have some seed data that gets put into the database before you run your tests. You need to know one of those IDs in the database, and you need to use this ID when you call generate. And we know that's not really a good idea because, for testing something like this, you should not need to populate any data into any database. And, as you may not even have a database, for example, in your testing environment, and then you would not be able to do something like this. So you try to be smart and try to make your tests a little bit faster. And you start making nasty things to the user class, right? You use mocking, which I have nothing against, but you would end up writing code like allow user to receive find with a particular ID and give you back something else. And the problem with doing something like this is that now not only your letter class is coupled to user, your tests for the letter class are coupled to users as well. Also, let's not forget that while the user class is our class, we've written it, the find method actually is not ours. It comes from Active Record. So we don't really know what other side effects we may be introducing by doing mocking like this. This is how we would then do it using repositories. So the class looks very similar, except it's got an initializer. And this is the really important bit of the slide. We actually tell this class when we build it, let's use this repository user to deal with users. So when you go to generate, this class will call still a find method, but it will do it on a user repository that you've injected when you were building the class. Now, why is this important? Well, maybe for this very particular case, not that much. But let's imagine that a few months later, requirements change. You've got a monolithic application. You're splitting it into microservices. And suddenly, your users are no longer coming from a database. So what do you do with this? Well, you have a problem, right? Suddenly, you need to change an internal method of a letter service because you've changed the way your users get persisted. And instead of those being in a database, they are in a REST API somewhere else. And this could be a REST API, or this could be a CSV file, or this could be, God knows what. However, with this approach, things are slightly simpler because the only thing we need to do is build another repository class that knows how to interface with the REST API. The advantage is when you initialize one of these classes, you just inject a new repository into it, and the generate method actually doesn't need to change at all. And by making this class less coupled, you are, as a side effect, also making it much easier to test. So this is, for example, a test for this class. We require spec helper. We require the class that we're testing. And we're telling our spec, build me a new letter service class and inject a testing repository that we can build in the test itself. So by doing this, the only thing we need to do when we want to test this is create a test repository, which can be very small. It can be in memory. The only thing it needs to know is have a find method that takes an ID and gives you back something, in this case, a test user that responds to full name. And again, this, if you need to change where your users are coming from, this test remains unchanged. It's not affected. This is what it's called, by the way, dependency inversion as well, which is one of the solid principles, the last one. So what this principle is telling you is that your classes should depend on abstractions rather than concretions, right? So this class is basically depending on a very concrete way of interfacing with users, whereas this one is interfacing with just an interface that knows how to get users from somewhere. You don't care where they're coming from. So this is pretty much what I wanted to talk to you about. So as a key bullet points, if you want, this is not by any means an anti-active record talk. Lots of people put lots of work and lots of effort into active records, and I think it's something you should definitely use and leverage. However, consider just keeping active record just in charge of talking to databases and pretty much nothing else. And we've seen, or we've learned, hopefully, how adding an abstraction layer between your data and your business objects can make your tests easier to write and hopefully a little bit faster. Some links that you can have a look at later if you want. There's this RomRB gem. It's a data mapper gem that has been in development for quite a while now. There's Hanami RB, which is what was before Lotus. It's a Ruby MVC framework that is gaining traction, and it uses the repositories instead of active records. And in case you're interested, there's a small explanation of these patterns I've talked about in the Martin Fowler webpage. And that's it. Thank you very much. Any comments, questions?
So if you were spinning up a new small quick email project, or something, that original, would you wait a little way in after it, or would you do it straight away?
Probably, yes. So I think one of the mottos of Rails is that you can literally have a block working in 10 minutes, and that's actually quite true. So I would say, if you're trying to spike something as a proof of concept, or if you are starting your own startup and you want to get to the market really quickly, by all means do this. On the other hand, don't wait until you have 300 active record classes in your application before switching to this, because then it's definitely going to be too late.
Is that your advice to basically start quick, start active record, take the first bullet, then start to implement the repository content? It's sort of what you would balance.
It depends. Like if you're in no rush to get out, like say you're an established company and you're suddenly, again, you have a monolithic application and you're splitting it into services. You want to start a new service, you want to build it in Ruby, you want to use Rails. You have a thing in production that currently works. You don't have to be shipping this new thing in 3 weeks. Then take the slow approach, do it right from the start, learn from your mistakes.
So I love that pattern, and I use it for a lot of projects. But I think one of the problems with this is particularly with active record. It's like they're removing the business logic from active record because there's so much that active record does is supportive of business. You have validations, which you can argue is business logic. It's not just about validating the data layer. You've got callbacks, right, after networks and things like that. Huge amounts of gems that assume that they're going to be interoperating in active record, and therefore it's state machines and what have you. So for me, I think the active record is particularly painful to differentiate what business logic and what isn't. And ultimately, some of that business logic is going to end up back in active record, and you're still going to have to test it. I mean, you don't write tests to say, does validate presence on the work, but you're still going to write tests saying, well, when I do this, I'm expecting the state machine to change because there's an actor network that's going to do this. So how do you handle that separation?
Well, I don't know the answer, to be honest. Those examples were obviously toy examples. For validation purposes, for example, you could maybe consider using some of the active model validation modules that will give some of these things to you, but will not actually talk to databases or anything like that. Yeah, you can find that alternatives. I think there's a gem called Rails ROM, which is meant to replace the whole active record layer by drive ROM, but I haven't used it. I don't think it's widely used in production, so maybe it's not that great.
Okay, just two comments on Slack. So the first one is, if you aim to write completely non-blocking tests, you end up writing better code because it's more decoupled.
You end up writing what, sorry?
The sort of, you end up writing better code by writing non-blocking tests.
Yeah.
In general, your code is
Yeah,
decoupled.
absolutely. Especially when it comes, for example, to changing it in the future. Changes to classes that are loosely coupled are just much faster.
And also, just another comment which is in praise of this approach, which is that if we have completely fast, non-blocking tests, it would be a revolutionary change because all of the tests could be run before code is committed, which is not necessarily possible in a large application.
Yeah, so that's, yeah, I mean, I think we've all seen the testing pyramid chart somewhere. So obviously, if your production system is still going to have to talk to a database, at some point you're going to have to test this. But the idea is you should be able to write incredibly fast unit tests at the bottom of your testing pyramid and just a handful of integration tests at the top.